When can you use your calculator? When can't you use your calculator? There are only 4 times that you can use your calculator to justify your response. If you're given a definite integral, then you may use your calculator. And that would be an integral from a to b of f of x dx. You don't have to integrate. So when you're in the calculator section, just be careful, because some of you will try to integrate things and you may not even be able to. And you don't want to take the time to decide can you or can't you. If it's a definite integral, like I have up here, just put it on your calculator. I don't even care if it's something you can integrate. Just put it on your calculator. So when you get to the calculator part of the exam, take your calculator and put it on your exam so you don't forget to use it. And even BC will do that. They have vector problems. They're almost always calculator. Well, they go and find derivatives by hand. You don't find derivatives by hand. You'll use your calculator. Integrals, derivatives, you can do with your calculator. Even if you're with a CAS, you may use the integrals and the derivatives. That's not restricted. Also, you can find intersections of 2 curves with your calculator. You're expected to be able to do that. And finding the zeros of the function. And the zeros are where the graph crosses the axis, the x-axis. But what you can't use it on, it's not to say you can't use it. You will get no points if you justify your answer just graphing the function. And last year, that's what happened. Question 3, the very last part of it was finding the maximum value of the function. And I firmly believe that many of my students, because they came back and told me, oh, I just graphed that. That's not okay. You have to set the derivative equal to 0 or undefined. And you have to find relative max, use calculus. To me, it's not fair that they put that into the calculator part of the exam, because you shouldn't have to be thinking about, may I use my calculator or not? But it is. And they said that was fair game because it's clearly stated in the directions. And it is. But I'm just going to warn you, there are only these 4 things you can do. So Tuesday before the exam, I will remind you about that so we don't have that same problem again. Okay? So, because we're going to run into a little bit of that here. So when you can, if it's a calculator problem, you may use your calculator to find derivatives and integrals, but not max mins. So let's do 2008, and it looks pretty ugly when I look at it. There's a lot of reading. But as we go through this problem, we go to the next problem, you're going to realize when you look at your answer, it's the same question, but in a totally different framework. I like this problem because it's talking about an oil slick. Where did we have one recently? In the Gulf of Mexico. So you had the oil spill, and then you had the cleanup process, which they're going to call the recovery. And it's still going on. And matter of fact, the loons were down there. I'm kind of surprised that they go that far south, but they do. And they're bottom feeders. And so the oil, they fear that the oil has gone to the bottom. And the loons have been eating the oil. So the loons that we have here could be poisoned. We just don't know yet. So all of this is extremely relevant. Unfortunately, I don't think BP even thought about a recovery process. See, my feeling is if you're going to drill for oil, I don't have a problem with that, but have your recovery process in place if it does happen to leak. And that's what's happening here. Oil is leaking from a pipeline on the surface of a lake, forms an oil slick whose volume increases at a constant rate of 2,000 cubic centimeters per minute. Now remember how I used to say, write down the find, given, and when? Write down the find, given, and when. So this is given that we have 2,000 cubic centimeters. You never know when they're going to give you a point for this. Per minute, right? What is that? Rate of change of what? It's music to my ears. It's the change in the volume. Think back to when we did this a long time ago. Now you automatically answered. So you have made that long-term learning jump. Okay. Let's see. The oil slick takes the form of a right circular cylinder with both its radius and height changing with time. That's important to realize. And if you think about an oil slick, it won't be a cylinder, but for our purposes, we have to do something easy. Otherwise, we can't do the problem. And they probably would approximate. Engineers are probably better. It's probably a better volume that they're using. But here's my cylinder. So it might start here, and actually I would think my cylinder is shorter and wider. It's really not deep. Does that make sense? But I can't get a cylinder to do that. I tried. I played with it. So here it is at one point in time, and there it is at another point in time. So both the radius, both the radius here and the height have changed, and that's important to know. That neither one is a constant, okay? They don't tell you things if, well, most of the time they don't tell you things if they're irrelevant. And it says the volume is right here, pi r squared h. At the instant when the radius of the slick is 100 centimeters and the height's 0.5 centimeters, guess what? That's my when, isn't it? So when, I might have this memorized by the end of the day. R equals 100, is that right? Centimeters, and the height equals a half, right? Well, I like fractions better. So when I do the problem, I'm going to change it to a half. Because I can do halves much easier than I can multiply by 0.5 in my head. Okay. What else we got? At this instant, what is the rate of change of the height of the oil slick? So what do I want to find? dH dt. You will be surprised at the number of points that you get for this problem and where you get the points. So the volume, they will tell you this, is pi r squared times the height. And I want to relate, and I should have said this in fourth hour, but this tells me what I want to relate. V and H, and I know R is changing, but for certainly I need V and H. And there's no proportionality. I don't know how R relates to the height. So I'm just going to take the derivative with respect to time, because I got to have a dV dt. And I'm going to put the d dt here. Now remember, d dt is an operator. It says, find out how volume or radius or height is changing as the time changes. That's what it does. It calculates the rate of change. So this is dV dt. And can I just pass the operator right through the pi? Yeah, that's pi times the derivative with respect to time of r squared h. Remember, you can ignore the constant. You can, well, I can't really totally ignore it, but I can ignore it in the derivative process. So dV dt. Now, r and h are both changing in time. What rule do you have to use? It's r squared times h. Can you take the derivative of r squared and then multiply it by the derivative of h? No. You have to use the what rule? Product rule. So it's r squared times the derivative of h with respect to time plus h. And what's the derivative of r squared? 2r times the derivative of r with respect to time. Is that 0? Is the radius changing? Yes. How do I know? Because, well, they told me they both changed. I don't have a dr dt here. I was hoping I did, but they didn't. Why is what? Oh, I do have that there. That's right. I missed something. What else do I know? I forgot it. It says the radius is increasing at 2.5 centimeters per minute. So I'm going to put that here. dr dt, and I'm going to answer your question, is 2.5 centimeters per minute. Okay, that helps. So I have dV dt, I have dr dt. And I want to find dH dt, so that should be a clue that I have to use the product rule. Because what is the derivative with respect to time of r squared? It's the derivative of r squared with respect to r. That's what 2r is, chain rule, times r is a function of time, times the derivative of r with respect to t. Algebraically, what happens to the dr's? They would cancel. Not legal, but it gets the point across. Does that make more sense now? Yes. Oh, because I goofed. Let's erase that. Because I did it. Because I was gonna write that. No, I did write this stuff out in the first one. Okay. So then I just plug in my numbers, and this was 2,000 equals pi. And I could distribute that, or I could do something else. What's the radius? That's 100, so I have to square it. Whoops. Okay. Times dH dt. And dH dt, oh, is what I don't know. Plus h. I'll go in order. I wanted to do the 2 first, but it messed everybody up. And h is 0.5, but I don't like 0.5. So I'm going to put in a half. Because it's a half times this 2 times the radius. And the radius was 100 times dr dt. And dr dt was 2.5. Actually, I'd make that 5 halves, but that's fine. And there's another parenthesis here, but I'm kind of out of space. And you have to solve for dH dt. Crazy as it sounds, there's only 1 point to get to that answer. You are on the exam, and you know you've done that. You're pretty sure you did everything right, and you look at that and go, I'm tired. I don't know what to do with that. I'm going to mess that up. So leave it. It's only 1 point. Make sure you get all the things where you get multiple points, like usually finding max. Finding where it's a maximum, justifying your response is worth more than a point. Getting to the final answer in a process is only 1 point out of the whole bunch. And I know this is only a point, and the next one we do it's only a point, so it's not worth it. But we're going to do it now. And you could distribute pi. The scoring rubric has it distributed, but we did in the last classes, we divided by pi. Because then I get 2,000 over pi, because it's easy. I mean, it's just as easy. You do not have to simplify it. It is a calculator problem, but you do not have to multiply it all out. This is dH dt. And just because I'm a math teacher, I don't like to leave 1/2 times 2. Because that's 1. And I can do 2.5 times 100, because how big is that? 250. It's just easier probably for you also to solve for dH dt if I do that. Otherwise, it looks complicated. So I'll subtract 250. Can we do this in one step? Once I subtract 250, this is gone here, and then I'll do what? Divide by 100 squared, right, 10,000. And now I got my point for my answer. Do you have to change it to the decimal? No. Now, was that bad? What's bad is that you have to realize that R and H both change, and you're going to have to use the product rule. I think that's what makes this tough. If you don't use the product rule, you're only going to get the first point, nothing after that. If you do the product rule, almost all right, you make a little error, like maybe you forgot the 2 or something. If you forget the RDT, that's a big error. But if you forget something little, and I don't know how you can really get much little wrong on this, you'll get still a point to get to the final answer if you get it right. Mm-hmm. They'll use your answer. If it's used elsewhere, they'll follow through on your answer. They do try to make it so that doesn't have to happen, because we don't want to follow through on your errors. But we do. I have a piece of paper there next to me, and when I find an error, then I go through and I recalculate. And so it slows me down in terms of reading. So we hope, and most of the questions and designs, that doesn't happen. Okay, so let's see what you get. Amazingly enough, this is 4 points just for A. So look at this. You get a point for writing this down. That's pretty nice. It's the point for writing it down. So everybody should have gotten a point. So it never hurts to take the numbers out of the problem, write them down someplace. Now, even if you don't write them down and you put them in here in the right place, I'm sure that they're going to give you the point. But you get a point for knowing that that's dVdt and that that's dRdt. For the reader, it's a lot easier for me to give you the point for this if you write it out. If you embed it in the problem, and I'm tired, I'm afraid I might miss it. And yes, we have people back read what we grade, but you may be one test that didn't get back read. There are loops. There are holes in the system. And then you get 2 points for dVdt. My guess is you're going to get 1 point for this, using the product rule, 1 point for putting the numbers in, and then you get 1 point for the answer. So if you look at this and you go, that's too complicated for me, I'm not that good with algebra, then skip it. Only 1 point. I'd rather see you get to the next part, because you can get the next part right, and you'll get more points. Because the next part's 3 points. That's only 1. Are you ready? So let's try the next part. the recovery device. And you have to think about this now. So now the oil's coming in, but they want to get rid of it. So we have a recovery device. Arrives on the scene and begins recovering oil, removing oil. The rate at which the oil removed is R of T, 400 square root of T cubic centimeters per minute. I'm going to write that down because it helps me. You don't have to. It may not be part of the question, but I don't know. I don't even remember from the last hour. R of T is equal to 400 square root of T, and it helps me also to have the units because it tells me something if I don't recognize what R of T is. The units are cubic centimeters per minute. What is that? It's the change in the what? Volume, as time changes. So it's a rate of change. So this is the rates of change that we're talking about. Okay, so this is how I analyze the problem. It says T is the number of minutes since the device begins working. Oil continues to leak. It didn't stop. It's still leaking 200 cubic centimeters per minute. So this has not changed. So you have some oil, more oil coming in and some oil coming out. Hopefully more is getting removed than what's coming in. Because if that doesn't happen, we have the fiasco we had in the Gulf of Mexico. How long did that take? 9 months? 10 months? It was a long time. We don't want that to happen. So it says find the time when the oil slick reaches its maximum volume. So how would you find the maximum volume? Volume max occurs when? You know this. When do you find maximum? When its derivative, which is what? dV dt, is what? Where are the candidates? 0. Now it's not to say it's going to be a maximum. This is an optimization problem, actually. And you can find dV dt. If this is the volume that you have, the volume, total volume you have is equal to the volume coming in minus the volume that's going out or being recovered. So how do you find dV dt? It's the derivative of the volume coming in. You don't have to write this, all this. I'm just doing it because I'm analyzing it, minus the change in the volume going out. What's the volume going in? 2,000. What's the volume going out? 400 square root of T. And I want where that is what? 0. I'm hoping it's 0. Do you see why the signs are positive and negative? Because this is coming in and this is being removed. Does that make sense? You have to watch for the signs. So I have to solve that thing. And I'm going to solve it here because I'm going to run out of space. So 200 minus 400 square root of T equals 0. You could use a calculator, but why? It's easier just to do it. Sorry, 2,000. So 2,000 equals 400 square root of T. And you divide by 400, what are you going to get? 500. Not 500. Cross out the zeros. So you're going to get what? Not 50. 5. And how do you find T? What's T equal to? 25. So it's 25 minutes. Remember, this is a lake. It wasn't the Gulf of Mexico oil spill. Mm-hmm. I'll race you. I'll beat you. Yeah, sure, you can. You don't. Nope. Let's show you what you get for points. I haven't finished the question, but that's okay. We can do this. Okay, there's the answer to the question. You get a point for saying R of T is 2,000. Basically, you get a point for this line right here. Setting that equal to 0. Or you get R of T equals 2,000. So when I said 400 square root of T equals 2,000, I got my point. Okay, and then I got 1 point for the answer. They don't care how you solve it. But I'm faster doing, because that was an easy one. If it wasn't an easy one, I wouldn't do that. But that was an easy one. If you wanted to guess and check and say, oh, 25 is what will make that true, Nothing wrong with that. There's no work. They're not going to grade your algebra unless it blatantly gives you an answer that's wrong. No, we haven't answered that question. So let's see what the answer is. Let's see what the question is. And it's, oh, first off, we have to justify it's a maximum. We haven't done that yet, have we? That's what I haven't done. It says, find the time when the oil slick reaches its maximum volume, justify your answer. You are pressed for time, okay? You have to justify that that's a maximum. How do you do that? I like it. Whoops, I was afraid I was going to run out of space. I like a little sign chart. This is not justification. Here's 25, here's dV dt. If this truly is a maximum, what has to be true about the sign here and the sign to the left, right? It has to be positive, negative. You are out of time. They are not going to trick you. I've never seen them trick you. If they're asking for a maximum, then it's going to work. And you would say it's a maximum because dV dt changes from positive to negative. Now, do you believe it really is positive and negative? No. No, they will not. They used to. You have to state that the derivative goes plus to minus. You have to actually make that statement. They're not going to know if you actually checked it. And they're not going to trick you. Now, watch. They'll probably do this the first time I've ever seen it. I've never seen them try to trick you. But, you know, you could say, okay, it's probably plus minus. Let me check really quickly. So what could I put into this equation, which was, where was it? Right here. So you can put in t equal to 0. Is that positive or negative? That's positive. Sure enough, that worked. If I put in t equal to 30, no, I better put in a value bigger. Okay, let's do 100. So it's 2,000 minus 400 times the square root of 100. Clearly, this is larger than that, right? So it's negative. So it truly is a max. Let's see how they wrote it, because I didn't let you see this. So now, by the way, this was 3 more points. This wasn't even that bad. I don't think it was that bad. What's bad about it? The reading. Isn't the reading bad? Not the math. Okay, it says dV dt is positive between 0 and 25. In other words, it changes from plus to minus. So it does reach its maximum volume. And the last part isn't too bad. And it says, by the time the recovery device began removing oil, 60,000 cubic centimeters of oil had already leaked. Right, but do not evaluate an expression involving an integral that gives the volume of the oil at 25. They want the maximum volume. That's what they want. So how do you find the volume? You want V of 25. How are you going to do that? Well, it's equal to the 60,000, right? That had already leaked in there, plus, and then you have to add up the amount coming in, which was 2,000, right? Minus the amount going out, square root of t, dt, and from where to where? Starting at 0 and going to how many minutes? 25. That's the last question. Sorry that I had to put it in the wrong place. I'll circle it in red so you can see it. Does that make sense? Oh, that was it 6,000 or 60,000? Now, I would still get the point because it's a copy error. And it's pretty obvious. I mean, there are some times when we have to look at it and say, okay, where would you get 6,000? If there was a 6,000 and a 60,000 in the problem, then I wouldn't get the point. But there's, you know, obviously I missed the 0. Silly me, which is, I've had a few copy errors. Okay, there it is. The volume of oil in cubic centimeters. There it is, 60,000 plus the integral. You're integrating the amount coming in minus the amount coming out. I want the volume. Anytime you say you want total or accumulation, you are talking about integration. Look at that. We use derivatives and integrals all in the same problem. What I like about this time of year is I like doing the problems. Okay, I know I'm weird. But I think the problems are interesting and kind of fun. But what I really like about it is it ties everything together. You know all the little pieces. Put it all together. start looking at the bigger picture and seeing what we're going to get here. And so sometimes it does get in my way during the school year because I still see the bigger picture. Well, you guys don't. So sometimes I have to be careful and not talking about that. Okay? Any problems with that? That wasn't too bad, was it? Do you think you could get 7 out of 9 points there? No? On your own? You can't write that? Would you not notice the product rule? Okay, but if the more problems you do, the better you get. Because you gain confidence, you go, oh, that's just like this problem. So let's do 2010, number 1, the snow problem. And we're getting snow tonight. Well, they said we're going to get snow, but it won't stay. But the ice is out. I graded this one. There are some things I don't quite remember about it, but that's okay. So we're going to read that one. And, you know, if you were from Southern California or from Florida, this problem might be a little harder for you. And I wouldn't do this. I mean, there is no snow on Janet's driveway. When the snow begins to fall at midnight, you almost wish you could go into another room and just read the question out loud, because I think that helps read it. For me, it helps to read it. From midnight to 9 a.m., snow accumulates on the driveway, which means it's going to add up, which probably means an integral, by a rate modeled by f of t equals 7t e to the cosine of t. Well, I like to get this stuff out of the problem so I can see it, which obviously I failed to do on the last problem because I missed the RDT. Okay. And it's cubic feet per hour. I might want to write that down because that tells me something. Is this a total or is it a rate? It's a rate. It's the change in the volume as time changes. Kind of like the oil slick problem. More so than you might even realize. T is measured in hours since midnight. Janet starts removing snow at 6 a.m. Okay, if we were at the end of the snow season this year, literally I was out removing the snow because I had no place to put it. But that's not what you'd say here, not in Minnesota. You'd go out and you'd shovel the snow. Oh, Mom, I'm going to go out and remove the snow. She might look at you like you're crazy. So I didn't like the wording they used. But what if you're from California? You've never had to do this. So this might be a little bit of a problem for you. I mean, I think there is an advantage from being in a northern state here. Okay, so she removes the snow using this piecewise function. So between midnight and 6 a.m., she doesn't remove any. In fact, I'm going to draw this graph because I think it helps you to visualize this problem a little bit. So between 0 and 6, no snow has been removed. So this is G of t right here. And this actually is a BC question. And I had assigned the BC question very similar to this, and the students decided they didn't want to do it because it was too hard. And lo and behold, it ends up being on the exam. And I said, you needed to have done that problem. But I also graded the AB and the BC ones of these. And first I started with BC, and then I did AB. BC averaged around, I'd say 4.5 to 5, or AB averaged around 3. So there was a significant difference between the groups. So the second year of the BC, you actually end up getting better at these things. Just experience, exposure. Okay. That's from 0 to 6. Then between 6 and 7, she's removing the snow at a constant rate, 125 cubic feet during that hour. Okay? And then she also removes from 7 to 9 at a constant rate at 108. What's happened here? Why has that gone down? No, still, she's tired. Yeah, she's tired. She's been doing this. I mean, what happens after a while? You get tired, you slow down. At least I did. Okay, so A, how many cubic feet of snow have accumulated by 6 a.m.? What's the key word here? Accumulate. So what do you have to do to this function? Integrate it. You're either going to take a derivative or you're going to integrate it. So the integral of, and you can say f of t dt, you do not have to rewrite that thing in there. From where to where? I want to know how much snow is on the ground. 0 to 6. And honestly, I don't know if that is a good model or not. And you have to integrate this. You don't know how to integrate that. My BC students do. They could integrate it by hand. I think some chose to do that, but it's a graphing calculator problem. Just put it in the calculator. So do you want to take time to do that? I don't know what the answer is, but I want to make sure you're always 3 decimal places. Now, a lot of you still have the old system. So I would put this into Y1. And it will look like this. FNINT, which is math 9. I think you already know where that is. And it's Y1, comma X, comma 0, comma 6. You can just use your calculator. And I don't know what the answer is. Make sure you're in radian mode because it does have cosine in there. As you integrate with the, and I saw that, by the way, saw people integrating with degrees. It was just like me to stop and say, okay, did they use degrees? And sure enough, I got my calculator out. I sit there with my calculator in front of me. I had 2 calculators, my 84 and my CAS. And I integrated it, and asked sure enough, that's exactly what they did. We will remind you over and over again. Just put it in radian. Anybody have an answer? What'd you get? Choose. Are you in the right mode? Yeah, I think that number sounds familiar. Okay, oops. Oh, I can't give you all the answers. Now, you have to have 3 decimal places. You can have more. We don't look past the 3rd, but you've got to have 3, or you have to have an exact answer. Now, the CAS calculator, because that can be integrated, might give you an exact answer. I don't know if anybody, you have one in here. You have to use it to see what happens. Okay. Oh, by the way, how many points? 1 for writing the integral. That's a 6. Sorry, I cut it off a little bit when I made the copy. And then 1 for the answer. So if you don't have your calculator, or you don't know what to do and you want to come back to this later when you're in the non-calculator section, well, you're stuck. You're only going to get 1 point. It doesn't matter. They just truncate. I don't know what does anybody know what the real answer is? 2, 7. Okay, I would write that whole thing down because it doesn't hurt. Because we don't look past here. The 6 does make the 4 round, but we don't look at rounding either. You don't have to round or truncate. That's why there's 2 answers. Notice it says or, it doesn't say and. One or the other. So, do you want pot roast tonight or do you want steak? It's one or the other. You don't have to have both. Or, what does it say? Do you want to go to the store or do you want to go to the lake? You can say yes. Drives me nuts. But it's a correct mathematical statement. Because one of them's true. Okay. B, find the change of the volume of the snow. I want the change in the volume. How do you get that? I want the change in the volume of the snow. Actually, I want that. So I want the volume of snow, the VDT of the snow, minus the VDT of the removal. It's this function. So you are going to, am I doing this right? Yeah, at what time? Because it says find the rate of change of the volume at 8 a.m. So this is at t equals 8. So I'm going to do f of 8, because that's how much is coming down then. You want to know how fast is it going out, and how much is being removed at 8. Now I got to look at my little chart. How fast are you removing it at 8? 108. So this would be g of 8 if you want to write that. So I don't know what the answer is, but it's minus 108. So it's f of 8. That's only 1 point. Ready for me to reveal it? It's only 1 point. What's f of 8? It's 56e to the cosine of 8. I don't know what that is. Minus 108. So what do you get for an answer? It's a negative number. 82967. That's fine. We will only look here. So even if you, I wouldn't, but even if you put the wrong things there, unless you get a greater, who knows? But you shouldn't have a problem with that. But if you don't have any work, if you don't have something that says something like this, and you just have the answer, you will not get the point. This is how they wrote it, like that. And by the way, we didn't grade for units. So if you did the units, fine. If you didn't, fine. Didn't matter. If you did the units wrong, you still didn't matter. We didn't look at them. Okay, but that was only 1 point. So if you just gave the answer, you'd only get the 1 point. So be careful with that. If there's any free response, if you don't show something how you get to a number, they will not give you the point for that. I know you thought I was picky, but once I learned that last year, I have to be picky, and you'll get good scores. Now, C was the tough part. That was this piecewise function. And they want H, not G and not F, but I want H to represent the total amount of snow that she has removed at any time. So I can easily do the first one. How much snow has she removed between 0 and 6? Nothing, right? She's sleeping. Or she's on the internet talking to her buddies. Whatever. She's not doing the snow. I know I have a friend that goes out there like every hour and removes the snow every hour. And I go, why don't you just wait till it's done? That's what I do. Unless it's coming down a lot, then I might do it partially through there, but I couldn't with my broken arm. So H of T is, what is that, the accumulated snow? Yeah, this is the amount of snow accumulated. Removed, sorry. At any time. So we're going to use this piecewise function I have right behind me. And between 0 and 6, how much have you removed? You've removed nothing. You got a point for that. You don't even have to write it in that little bracket or anything. If you just say between 0 and 6, she's moved nothing, you got the point. Now the next part is what's tough. I want to know the amount of snow that she removes in this interval. And it isn't 125. It's 125 at the end of the hour. This is 125 cubic whatever per hour. So what about 6:30? She hasn't removed 125 cubic feet. She's removed half of that, right? So if I look here at my graph, this might help. So I want to know how much snow has been removed here and then here. I want this as a function of time because I don't want it at a particular time. So what do I have to do? I have to integrate this function, but you don't even need calculus. You don't have to write as an integral. We will, because I like it better, actually. I just figured it out, but I figured it out wrong. You'll see why. It's the integral from 0, oh, not 0. The 125 didn't start till when? That's what I did wrong. It starts at 6, but I don't want it to end at 7, because that's for exactly 1 hour. I want anywhere between 6 and 7 of this 125. We did not mark it wrong if we missed the DT. There are a few of us that aren't happy about that, but that's the way that works. We didn't get picky about the inequality symbols either. So if you close them all, we didn't care. If I integrate that, I'm going to get 125t evaluated at 6t. So that's 125, and I shouldn't mix my variables, but I did. And that's t minus 125 times 6, which I have no idea what that is. So I'm going to factor out 125, and this is t minus 6. It's a translation. You're not starting at midnight. You're removing snow at 6 a.m. So I have to say it's 0 at 6. Does that make sense why it would be t minus 6? Because I did a 125t. I go, oh no, that would be starting to remove the snow at midnight. She doesn't remove the snow at midnight. She doesn't start removing the snow until 6 in the morning. That make a little sense? Either way, a lot of kids did this, other kids did that. Most people did not do this. They just didn't even do the first one, which was easy. Okay, what about the next one? We'll see if this is okay or not. I want between 7 and 9. But how much has she removed in this first hour? Has she removed 125 in 1 hour? That doesn't change. By the way, this was a BC question. Did I say that already in here? And they didn't practice it, which is unfortunate. because it would have made it easier, plus, and then you have to figure out how much she removes, not between 7 and 9, at 7 and t, because at 7 she hasn't done anything at 108 cubic centimeters per hour, but at 8 she's done half of that. She's done 54, right? And at 9 she's done the 108. But you have to have it be partial, so it's 7 to t of 108. This is a problem in my BC book. You never saw one like this, did you? Because it's still a concept that is needing to be tested, or is being tested. And they said they're going to do more piecewise functions. Now, they could have made this actually 125t and made it be not a constant graph. So you didn't need calculus to do this, because this would have been 125 plus 108, and this would be t minus 7. Most people didn't get to that one correctly at all. And then, of course, you think, well, then I can't do the last one. But yes, you can. Actually, they got the last one right. So it was 1 point for this, 1 point for either the integral or writing it this way. It didn't matter. Same thing here. 1 point for this one with the integral, or 1 point for that. I didn't mind just writing it out because I knew it was just a simple linear function. And then the last one, of course, I got right, because that wasn't too bad. They want the total amount of snow you remove by 9 o'clock in the morning. So, is that D? Total. Well, between 0 and 6, you've removed nothing. Between 6 and 7, how much have you removed? 125, right? Between 7 and 9, how much have you removed? 108. How many hours here? 2. Where was the mistake? Well, most of the students put 1 hour there, because it's 7 to 9 o'clock. If you look at your picture, you can see that. Now, that's how much you removed, right? So how much snow remains? You have to integrate, because it's falling down. F of t is the amount of snow coming down from where to where? 0 to 9, that's right. And you're going to remove this, minus 125 plus 2 times 108. I don't know if this was 3 points or not. I don't remember. We'll have to look. This, I know, is a point. Knowing that. We look? I just don't remember. Okay, there's the answer to the other one, and I said you could write it either way. Any way you like to do it. Okay, so it is 3 points. 1 point for writing your integral. 1 point for this guy. 1 point for knowing it's, you don't have to say it's h of 9. I didn't say h of 9, and I didn't. You could say h of 9. So you could have written h of 9 here. Or you could have just done what I did. Most of the students did that. And then 1 point for the answer, which was that? 26.334. One of the, after you guys take the exam, I get on the internet and I go and look for comments. The one kid wrote, okay, I read the first question. I had no idea how to do it. Okay. Right. So the kid writes, first question, no idea how to do it. Then they went to the second question. We did the second question, wasn't that yesterday? The second question with the max min? 2 days ago, what was that about? It was about the baby elephant names. Okay, he read that. He said, okay, I don't know how to do this. And then he went to the third question. What's the third question? We haven't done that one yet. He just looked at it and says, I'm done. Because that's what you want to do. If you look at the first question, you say, okay, I really don't even know where to start in this. Look at all of them, and then pick the one that you feel most comfortable. Yes, we're done with 1. We've done 1, 2. We did 4 when we reviewed chapter 7. And we did 5 yesterday. Yeah. Now, number 4, it would not be considered part of your homework quiz. But the other ones would, 1, 2, 5. That's just from 2010. So we've done 4 parts out of the 2010 exam. I think it was a hard exam. It wasn't curved very much. Not as much as in the past, because the chief grader says, I'm not going to do it. They don't know it, I'm not going to give it to them. So that's what happened. I always do that. So what should you be doing? Honestly, somebody figure out the math. Maybe I will during lunch. If you do 2 problems a night until the exam, don't forget to do multiple choice questions so you feel comfortable with those. They're only 4 years. Start with 2008. If you're going to cut yourself short on multiple choice, do 2008, 2003. There are things on 1997, 98 that are not being tested anymore. Do those. Work backwards, because your exam's going to be more like those. And there'll be some things. If you look at 1997, 98 and say, I don't know how to do that problem, you probably don't. You can look at my answers and it looks like something we've never done. Because I took integration by parts off. There are some things that have been taken off. So you don't have to worry about those. But you won't necessarily know what they are. But if you do 2 problems a night, all the way up to the AP exam, that's a half hour. I think you'll be just fine. But don't wait till the week before the exam. It's way too late. Problems we've done in class, and then anything else recent, just recent, of 2009, 2008. We probably don't go back, maybe 2007. But there's a lot of problems here, but you don't have to do them all. But what's your advantage? Why are we doing this? Because we're trying to motivate you to do them and not wait till the end to do them. Right here on the bottom, it says F, max, min, concavity, etc. That's the focus. This little thing here. I apologize that I messed up on the assignment sheet. So, sorry. We'll put it together. I'll try and get it right this time. But look at all that. So it tells you it's important, doesn't it? Because look at how many are there, and then look at this. F to F prime graphs aren't as that many. It's a pink one, actually. You should have it, but you can take that. I got a zillion of them. And they're online, too. And it's time for lunch. Okay, you guys have a good weekend, and make sure you remember study session is Monday night, 6 o'clock to 9. You can come at any time. Well, don't come at 8:45. But you know what I mean. It's not, you have to be here for the whole time. Nothing like that. Oh, no. Oh, okay. Okay.